x. So of course this one doesn't make any sense for us, and this is 5.39. So again, how does this work? So this is the 5.39 feet. This is 5.39. This is 9.2. And this is 2 feet. And that was a word problem in which...
Wait, which was the 5.39?
Yes, the maximum distance where it hits the ground, the X-intercept. Is that okay, everyone? The X-intercept. So we used the model that we just studied, which is the quadratic model, to fit the information given to us. Throwing of a ball up and up in the air. Not just up like this, but up and outward, of course. Any questions? Any questions? Any questions? Yes.
Do you still have it on your calculator?
Yes, of course. You want to graph it, or?
I just want to look at it again.
Yes, of course. Yes. Here, this one?
Yeah.
Yes, yes, of course. Is this okay, everyone? Did we get the same answers? Yes? Let's take a look. Did you put enough parentheses?
I'm gonna do it again.
Okay, but it's not negative. We changed it to positive.
The one up top.
No, I changed it to positive. The top, the first one is wrong. Because I picked and chose. 64. Plus 8 times 15. Plus. It's not minus. We change it to plus. So forget about the first one. You have to erase the first one completely. Times 15. Close the parenthesis. Close another parenthesis. Without the second parenthesis would not make sense. And divide by 4. And you should get the first answer, the 5 points.
Should have been parentheses behind the 4.
No, you didn't. So this is multiplied, not
The top one was
so it's multiplied.
I think the top
When
one
she
was
first multiplied it, and when she multiplied by negative,
Is that okay?
She just made everything positive. So the first one was negative, the other two were positive. So when she would flip, it would put.
So when you multiply 3 terms by a negative number, you have to multiply 3 terms. I only multiplied the first one. I
We
was
carried
talking
10 all the
and
way through, but not the negatives.
yeah. So I was talking and not doing what I was supposed to be.
Ignore the top, because that was from when we did that the wrong way. The two on the bottom are the plus or minus.
Right? So I changed. So when I multiply this by negative, this has to be multiplied by negative 10, and this by negative 10. I was talking, no excuse, my apologies, and I did not follow through. I was explaining, and I only multiplied the first term, not the other two. I cannot do that.
When we catch it.
Is that okay? So when I multiply the first term by negative 10, I have to multiply the second term by negative 10. I have to multiply the third term by negative 10, as well as the other side. So what I did, my mistake was, I multiplied the first one. I said something, and I forgot what I was doing, and instead of multiplying the other two. And how did I figure it out? Because I punched it in the calculator, and I was getting negative numbers. One of them has to be negative, but not both. So I realized, oops, something is wrong. Go back to the drawing board. So I said, oh, okay, here's what I did. Is that better?
Yes.
Perfect. 3.2, polynomial functions. Polynomial functions. Better? Please stop me if you have questions. Anytime. Okay. Polynomial functions, yes, the first one is linear. Done. The second simplest one is quadratic. Done. Well, now the situation it becomes a little bit more complicated. Third degree, fourth degree, and so on and so forth. These are more complicated. They have more steps in graphing them. So I would like us to graph an odd degree, an even degree, and then look at word problems. Okay, so here is the situation. We looked at an example a few minutes ago, and the example was, at any point in time, when I throw a ball upward and outward, it will follow this trajectory, which is clearly quadratic. But what if, I'm trying to explain why we even need to look at these functions. Why? Isn't this enough? Linear, quadratic, why do I have to go fourth, fifth degree, and so on and so forth? Here's the situation. A model from a real life case can look like this.
Like a basketball.
There is no function like linear or quadratic that will fit this information. I can have something like this. This is not a function that we studied before. You cannot, through the information, through the data set, you cannot fit a linear function. You cannot fit a quadratic function. So this must be different. Okay? So let's start with two different situations we have here. Odd degree, even degree. Let's choose an example from each in which we were going to study the function like we did with the quadratic, x and y intercepts, domain, range, etc., etc., for both of them. And then we're going to look at when they are applied. I let you choose any problem you'd like on page 378. We have to look at one odd degree and one even degree. And you can say more. I would be more than happy to do more than just one from each. However, once we understand the odd degree, for any odd degree, like a degree 3 or degree 5, we will be able to graph any odd degree. They're all the same. Very similar, I should say. If we understand how to graph a 4th degree or a 6th degree, we will be able to graph all of them. Any even degree at any point in time. Okay, so on page 378, if you'd like to choose, if not, I will choose between 41 and 64. Let's start by looking at an odd degree. 49. It is an even degree, degree 4. It's an even degree, it's degree 4. You want to start with an even degree? That's fine too. 49 is fine. F of x, negative 2x to the 4th plus 4x cubed. That's fine. It doesn't matter. I thought we were going to start with an odd degree. It doesn't matter. Oh, you said 41. Oops, I'm sorry. 41 it is. F of x equals x to the 3rd plus 2x squared minus x minus 2. So we picked two functions, one that is odd and one that is even. Excellent. Very good. So we are asked to graph it. Graph f of x equals x cubed plus 2x squared minus x minus 2. Excellent example. Good pick. So here's my first question. Number 1, domain. What is the domain of this function? That's always the case. We always start with a domain when we are asked to graph a function. Of course.
The range is probably what's going to limit, but
Of course. So is it clear why the domain is all real numbers? Exactly. You don't have a square root. Awesome. Well done. That's the correct answer. Thank you. So indeed, all polynomial functions are defined on all real numbers. Number 2, the list will be given to you, the list of items. Once you graph 4 or 5 functions, you will always remember the steps. But I will mention the steps for you. Domain. Perfect. Next, X-intercepts. And there is something we have never discussed before. And their multiplicities. We don't know what that is yet. I will explain it right now. So X-intercepts and their multiplicities. Okay, I want to explain my multiplicities and then we'll go back to our function. Let's suppose I have x plus 1 to the 4th times x minus 2 equals 0. So this is not related to the function. So this is explanation. What is the degree of this piece? Awesome. Well done. What is the degree of this piece? When I multiply degree 4 by degree 1, what degree do I get? Excellent. X to the 4th times x, copy the base, add the exponents. So this is degree 4 and this is degree 1. So x to the 4th times x, copy the base, add the exponents. Degree 5. How many solutions will this equation have? Absolutely. Awesome. Great job. You remember what we did a long time ago. I'm so happy to hear that. So then, can anyone give us 5 solutions? So 5 solutions. Please give me 5 solutions. Yes?
0, 1, and
We have 4 factors. We have 4 factors that are identical. So you must give me 4 solutions that are identical.
-1, 1.
4 solutions that are identical. X plus 1 to the 4th power means x plus 1 times x plus 1 times x plus 1 times x plus 1. You can't change that. So you have to give me 4 solutions that are identical, which are? Do you all agree with this? Good. So then I'm going to ask you, what is the multiplicity of -1? How many times exactly? How many times x equals -1 appears as a solution? Excellent. What is the multiplicity of this solution? 1. And you can say, why is this important? In a minute, I'll explain. Very important. Is it clear? Okay, here's another quick example. Let's say I have x minus 4 squared, x plus 3 to the 3rd, and x plus 1, and I also have an x in front. What is the degree?
And that's 1 in the end too, right?
Everything.
6.
1 plus 2 plus 3 plus 1. 7. Degree 7. How many solutions will you give? 7 solutions. I want a list of those 7 solutions, please. 0.
You want to from left to right or like numerical?
From left to right.
Then you're going to have 2 4s, 3 -3s.
You cannot change anything. It's just they're identical. You cannot say plus or negative, plus or minus 3. You have to
Obviously,
say.
you're going to have -3 3 times.
Oh, yes, of course. Thank you. Good.
And negative
And -1. What is the multiplicity of 0?
1.
What is the multiplicity of 4? What is the multiplicity of -3? And what is the multiplicity of -1? All this have to give us 7. 1 plus 2 plus 3 plus 1. Is that 7?
Yes.
Perfect. 1 plus 4. Is that 5?
Yes.
Perfect. And now I'm finishing the explanation by telling you what does that translate into the graph. Why is this so important? Why do I care to know that 0 has a multiplicity of 1 and all these solutions have different multiplicities. Why is this important? Here's why. And then we'll come back. Say it again.
Well, it turns across.
Exactly. That's exactly right. Tony is right. So let's take a look.
Does that mean fully cross or does it include touch?
Touch and
So,
Touch it?
turn. Touch it and turn.
so if it turns, it touches.
Okay.
If it crosses, it does not touch. It crosses.
Gotcha.
Right? Okay. So for an odd multiplicity, what do I mean by odd multiplicity? 1 is an odd number, 3 is an odd number, 1 is an odd number, 1 is an odd number. For an odd multiplicity, the function will do this or this or this. It still crosses. It's a cross. Any odd multiplicity is mandatory across. But what type? This one is a multiplicity 1. This one is a multiplicity 3. This one is the multiplicity 5. And the higher the multiplicity, the slower it crosses. Still ones. Although there are 5 solutions over there, but they're not 5 different points, it's 1 point. So if there is multiplicity 1, the function will cross straight. If it's multiplicity 3, it will take its time.
Because it's how many, like, it would be like if you wrote down like the 5 separate dots, it's going to take up more space than.
If you want to say that. Okay, about the even multiplicity now. Here's an even multiplicity. See the difference between these two? It's still only 1 point here and only 1 point here, but you see the difference. This is multiplicity
2.
So this is even. And this is 4, and so on and so forth. The higher the multiplicity, the slower the process. Okay. So this was, I introduced multiplicities, how many times the solution appears, and how will that affect the graph of the function. And these are the 2 possibilities. If it's an odd multiplicity, it will always be a cross. If it's an even multiplicity, it will always be a turn. Cross or turn. Okay, so we are back to our function. We are still in number 2, and we have X-intercepts. And the function, one more time, is x cubed plus 2x squared minus x minus 2. I'm sorry? I just copied it one more time because I'm 3 pages later. And I wanted you to see what I'm doing. Good. So how do we find the x-intercepts for any function, including this one? Always, for any function. Excellent. So I have x cubed plus 2x squared minus x minus 2 equals 0. This should ring memories, because we've done this several times. So what do I do now? How do I solve this equation? And what type of equation is it? Indeed, it's a polynomial. How many terms? What do I do with 4 terms? Thank you very much. That's my hope. Good. So please remember, do not look at the last 2 terms. You may make an error. If you have a different method that works for you, please use it. From the first 2, what do I factor out? Great job. What do we have in parentheses? What do I have to write before I look? And do not forget the equal symbol and 0. Only now I look. Excellent. So I factor out x plus 2. I have x squared minus 1, and I can continue. I know this. So this is x plus 2. And how do I continue with x squared minus 1? Excellent. Both of you, excellent. I should have asked, and I didn't, forgive me. Degree, please.
3.
How many solutions?
3.
Good. So please give me those 3 solutions. Excellent.
-2.
-2, -1, and 1. Multiplicity for -2.
1.
Multiplicity for -1. Multiplicity for 1. So, at all these points, the function will turn or cross. What will it do? Straight cross. Nothing fancy. Very good. Number 3. Something we have never discussed before. And behavior. We did discuss it, but I didn't mention it like that. We had to wait till polynomial functions. Okay, so let's take a look about the end behavior. What does it mean? What does it mean, end behavior?
If it's going to hit up or down.
Exactly, where it's going, eventually, right? So if I graph x squared, what would be the end behavior of x squared? From positive infinity to, that's it.
So it's with that leading coefficient now? If it's a
It
positive,
depends.
it's
It depends on the leading coefficient. Yes. Okay. For even degree. But now let's think about the odd degree. Do you remember any function that it has an odd degree? And yes, you have to say linear. Linear function is an odd degree. What are the options for a linear function? Because the linear coefficient is positive, and it comes from negative infinity to, what if it has a negative leading coefficient?
Yeah, it goes from
It's coming from,
positive going into negative.
that's it. So there are 2 options here for odd degree. That's what we're talking about right now. For an odd degree, the options are this or this. This one means from negative infinity to infinity, and this one means from infinity to negative infinity. If the leading coefficient for this one, if the leading coefficient is negative, and for this one, if the leading coefficient is positive. So, let's look at the function and identify the leading coefficient. What is the leading coefficient in our example?
1.
Because it's a leading coefficient that is a positive, then the function will come from negative infinity to positive infinity. This will be the end behavior. And this is the perfect time to start a table, to summarize all the information. Summary in a table. So in part A, we learned that the domain was all real numbers. I put it in. That was a long time ago because I took the time to explain multiplicities. So we said the domain all real numbers. Now we have the X-intercepts. The X-intercepts in order are -2, -1, 0 will always be in the table, and 1. What is the function value at -2, -1, and 1? Of course, they are the X-intercepts. Indeed. And now we established that the end behavior for this function is, one more time, because it has a leading coefficient that is positive, it's coming from negative infinity and going to positive infinity. We summarize in this table. Yes, of course, this problem is going to take us a long time, right? It's the first polynomial function we looked at. So this one will take 15 minutes or 20 minutes even. But the next one and the next one and the next one will be less than that, like 4 minutes. Okay, so we have the end behavior. We put it in the table. Step number 4. I know I only have 3 minutes left. I'll stop in 3 minutes. I may not be able to finish, but it's okay. Of course, y-intercept. What I would like to mention on the table also, I'm going to say cross cross, and cross. It doesn't mean cross flat or slow, it just means straight cross.
We have to do this table.
Absolutely, yes.
This goes with the end behavior.
No, but if you don't summarize the information in a table, you're not going to be able to graph it. It will be very difficult to graph. The y-intercept. How do we find the y-intercept? Yes, f of 0. That's the easy task. Exactly, 0, 0, 0, negative 2. So 0, comma, negative 2. So this is negative 2. Step number 5. Max or min, and I know you're going to like this, with TI 84 or 83. We cannot do this by hand in this class. If you take the next class, you will be able to find it without a calculator. Max min with the graphing calculator. Number 6, symmetry. If you remember, there are two different types of symmetry. When f of negative x equals negative f of x, and when f of negative x equals f of x. We learned this a long time ago. What is the first one? What type of function is the first one? So this is odd function, it's not connected to the degree. It's odd because it's symmetric with respect to the origin. What type of function will this be?
Even.
Yes, which means symmetric with respect to the y-axis. I wanted to point out this method in the book. This is what we're doing is exactly the same thing, but I'm showing you to summarize the information in a table because this is very important and very much easier to put everything together. I know I'm almost done. So number 7, max possible number of turns and the degree. One more time, what is the degree of this function?
3.
Perfect. Max possible number of turns is degree minus 1. If the degree is 10, the function cannot turn more than 9 times. It cannot have more than 9 max min. That's what the turning point is. In this case, the degree is 3. This function can never turn more than twice. Does it have to turn twice? No, it does not, but it cannot be. So for example, if you remember f of x equals x cubed, what is the degree?
3.
What is the maximum possible number of turns?
2.
Does this function ever turns? No, we graphed it. Here's the function. It never turns. It's increasing all the time. If a function turns, it has to be increasing and then decreasing and then increasing and then decreasing. X cubed never turns. So we didn't get the chance to graph the function today. That's okay. We will graph